Good afternoon, everyone. I'm Edan Yago. For the last 14 years, I've been working on what frequently has been an unpopular mission, which has been to bring greater scalability and functionality to Bitcoin and allow Bitcoin to be a fully programmable system. The reason I was interested in this is because I would like, as someone who holds Bitcoin, to be able to use my Bitcoin without going through intermediaries. I also would like to make sure that Bitcoin is future-proofed and is able to adapt and adopt to new technologies over time. Now, weirdly enough, to me at least, this has been an extremely unpopular idea. It's been unpopular from the perspective of people outside of Bitcoin because they've said, well, you know, Bitcoin can't do these things, and in fact our livelihood depends on the fact that Bitcoin can't do these things because it allows us to launch systems which can. And it's been unpopular, weirdly enough, inside of Bitcoin because people have, especially over the last 7 years since the block size wars in Bitcoin, sort of been held in a Stockholm syndrome or a Maxi syndrome, where they've been held hostage by the limitations of Bitcoin and have become so used to the limitations of Bitcoin that, like hostages in a Stockholm syndrome situation, they've come to identify with those limitations and even begin to worship those limitations and see them as crucial, important, valuable, etc. Despite that, there's been always a group of people who have believed that we have been perhaps underestimating the importance of Bitcoin because we've also been underestimating the importance of network effects in our industry. Effectively, what we're building are networks of assets and networks of money. Now, networks obviously have network effects, but this is compounded by the fact that money has a network effect, that liquidity has a network effect, and that developer ecosystems have network effects as well. So it has always been my belief that what we would end up with is a relatively small number of networks in a winner-takes-most environment, and that we were heading towards that kind of consolidation, and that further, the primary thing that was holding us back from getting to that point was the limitations of Bitcoin, which created an artificial situation where Bitcoin itself couldn't fully express its network effects. And as a result, we had an industry which was built on a constant process of greater and greater fragmentation. More chains, more confusing UIs, more ways in which liquidity, user bases, and tribalism got broken up. So for 14 years we've been working on this, but the big opportunity for us, right, and sort of the ways that we've been working on this, just to give you guys a bit of a sense of who I am, one of the ways in which I've been working on this was trying to build Bitcoin more deeply into the financial payments rails, so the payments rails themselves could become more decentralized. To do that, I started a company called Epiphyte. Epiphyte became one of the first companies to do significant cross-border transactions and remittance settling in Bitcoin. And among other things, the first sort of versions of Lightning Network were invented inside of Epiphyte. Later, I started a project called Sovereign, which became the largest DeFi platform for Bitcoin, but still within the limitations that Bitcoin had at the time. And then Taproot introduced new types of cryptography that we could use with Bitcoin in 2021. And myself and a small number of other researchers became convinced that the next big leap for Bitcoin was opened up already back then, because Taproot opened up the opportunity, the possibility for us to introduce ZK verification into Bitcoin. And the reason we thought that this was so important, I will be mostly talking about in this talk, but I'll summarize it in one very, very simple idea. which is that for the last 10 years, we've lived in a paradigm where the way we've built additional expressibility, programmability applications into blockchains has been by taking everything, the entire software stack, the VM, the data, and all of the computations, and shoving them into the blockchain itself. And then every single node and every single validator or verifier needs to rerun every single computation that the system produces. And we have discovered, although I think it was obvious from first principles, that this would not scale. Right? We've seen the struggles that Ethereum has had with scaling. We've seen the struggle that Solana has had with scaling. We've seen the trouble that every single system that uses this paradigm has had with scaling. And that kind of system exists to produce smart contracts, which are basically verifiable compute via redundancy. Everyone reruns the program, you get enough redundancy, you can make sure that the program is run correctly. But what ZK introduced is the opportunity to have verification via cryptography. Perhaps a single machine could prove that it had correctly run the program in such a way that would not require everyone else to redundantly rerun it. So that was the big idea that we thought was going to change everything, and we think right now we can start seeing the early phases of it changing everything. But what we had been working on was, can we work within the limitations of Bitcoin, which are extremely uncomfortable. If anyone's ever tried to build on Bitcoin, it is an extremely punishing system, right? It is not a system which is designed to make it easy to build on. Can we get a system where we could build a ZK verifier using the existing opcodes on Bitcoin, using the existing stack limitations, using the existing data limitations, etc., etc., etc.? Towards the end of 2023, we thought we had cracked the code. In April, we published a paper called Bitsnark and Grail. And then last year, for the first time ever in block 853.626, we were able to demonstrate on Bitcoin mainnet the first ZK verification that had been performed. And the way that we did this, I think, is quite interesting. I'll mention it very briefly, which is that we basically created the ability to utilize fraud proofs with ZK to allow for ZK verification to be done on Bitcoin mainnet using Bitcoin opcodes. So that was great. But what we had learned in the course of building this was really, really compelling. We had discovered that this might be far more interesting and far more flexible than what we had initially anticipated, which was that we would, initially our expectation was that this was going to allow us to build roll-ups on Bitcoin. And over the last year, what we've seen is a very large number of ecosystems as well as developers sort of working on their own, beginning to take more of an interest and begin working on our system in ways which we didn't initially anticipate. And what has emerged, perhaps as the most exciting aspect of this, is not the ability necessarily to just build rollups on Bitcoin, or even the ability to utilize ZK bridging to bridge BTC in a highly trust minimized, effectively trustless for those who are operating the system way, but the ability to rethink how we think about computation, how we think about smart contracts, and how we think about tokens more generally, in a way which I think is extremely interesting and applicable to the entire crypto space. So looking at this, right, if you think about the way we think about smart contracts, and by extension tokens, which are all created by smart contracts today, you have a monolithic system, right? You have an instruction set, you have a hard-coded VM, and you have the pooled asset. So think about when you're just creating even the simplest smart contract, that smart contract is the instruction set which generates the tokens, and it is also the system which manages the registry of tokens and the transactions of the tokens all within that system. And as a result, it is extremely inflexible and hard-coded to whichever chain it exists on. Now, we've been hearing about modularity in the crypto space for a long time now, but what Bitcoin has effectively forced us, because of its limitations, to do is to think about, perhaps take modularity to its to its limit, right? To its logical conclusion, which is that the very programs themselves can be modularized. The instruction set can sit anywhere on a computer, perhaps not even written, right? Not written on some computer, on a single device, not even on the blockchain, so long as everyone has access to that instruction set when they are interacting with it. So it could exist, for example, in GitHub. You can abstract away the necessity to have any specific VM by allowing developers to build in Rust or in C++ or Solidity or whatever it is they choose, any RISC-0 or WASM system, by encoding everything as a ZK proof via a ZK VM. And you can, as a result, create assets that don't exist on a specific chain, but exist as specific ZK proofs, tiny little proofs representing the token itself, and all of the history of that token being represented by the fact that the proof is recursive and that the inputs themselves represent the smart contracts that allows. And this created a new paradigm of us thinking about both smart contracts and tokens, which we today call charms, which allows us to turn Bitcoin into a general purpose ledger. But perhaps what has been most exciting to people is the fact that it allows us to issue, or rather to allow developers and users to issue tokens where, with a simple proof, they themselves, without going through any third-party bridge, can port those tokens to a different execution environment, to a different chain. And so it's actually really cool to me that up here a moment ago was Starkware talking about something very interesting and exciting, this idea that you could have a roll-up that sits between the worlds of Ethereum and Bitcoin. But I would effectively suggest that we are here on the other side of that, and suggesting that perhaps instead of thinking about entire chains as roll-ups, we should be thinking about every single asset, every single intent as effectively its own roll-up. And what that does is it creates a world which looks a lot more like the internet. One of the things that made the internet so successful was its absolute dumb simplicity. All data, regardless of what it is going to be used for or how it is constructed, is shared across the internet using standardized packets, internet packets, right? So we've sort of modularized the internet into this very fine grain of tiny little packets, which only contain small components, the minimum components of that are required to be transported. Well, what are we building? Sometimes I think our language confuses us. We sometimes think of ourselves as the blockchain industry, but no one really wants a blockchain. What we are actually focused on in our industry is assets, is property, and is the proof that allows us to own or transact in those. In other words, we are an industry focused around crypto. We're an industry focused around proofs. And by constructing a system where the tokens themselves, the intents themselves, the transaction themselves are all demonstrated via proofs, we abstract away the question of, are you on a chain or are you not on a chain? What kind of chain are you on? Are you an account-based chain or a UTXO chain? And allow for things like tokens which can move from one chain to another and continue to interact with the same smart contract, which could even be on a third chain without the need for bridging. Now, we were sort of led here because of the fact that Bitcoin is a harsh mistress, because it is so limited that anything that we could construct for Bitcoin by default would then work for other systems as well. And our goal was to build a system where, the world's most trusted ledger would be able to have real-world assets issued on it, or be utilized for proving the most important pieces of data, or building a system which was flexible enough that a company would be able to build using Unity, right? And C++ and running a game on their own on their own servers, but still be able to prove the key components of the properties, assets, loot drops to a chain like Bitcoin. And so effectively our goal was to turn Bitcoin into the ultimate trust anchor for different assets on Bitcoin. But what we've discovered is that the primary users, the people who are most interested in working with us, are actually developers who are building other ecosystems themselves, right? Chains like Litecoin and Cardano in the UTXO world, Sui, Tron, BSC, Arbitrum outside of it are recognizing that two things become possible now. One is the ability to gain trustless access to BTC in their own environments, but also by integrating into a system, for the first time we have a trust anchor not just for assets, but for chains themselves. In other words, Cardano can now interact with, for example, Litecoin, and I use those two as examples because we've been focused primarily on the UTXO chains initially, as those are the easiest ones for us to integrate, through Bitcoin. In other words, Bitcoin can become a single trust anchor in a way which is very, very different, right? Where, for example, in the talk before us, Starkwear was suggesting, let's have a rollup which is sort of split between worlds and is trying to have trust anchors into Ethereum and Bitcoin. What we're suggesting is that a more cohesive way of working for the entire crypto space is for us to have a credibly neutral system which we all agree to use as a central provider of security, and then by default that is Bitcoin, and that because that is so valuable to do, naturally that is where we expect the industry to go, and we're glad that we can help provide technologies that make that possible. And what we think that that does is it takes us from a world where for the last 15 years we've been talking about building an internet of value and effectively failing, and instead of that building many chains that compete with each other, but because of that can't truly compete with the internet, into a world where we can start talking about an internet with value, where Bitcoin and by extension the rest of crypto become just another pillar of the existing internet. Interoperable not just with themselves, but with everything that we think of as Web 2 and people are starting to talk about as Web 2.5. So I started this journey because I believed in the power of network effects and the ability to utilize Bitcoin to build a more decentralized world. What I've discovered is that probably the path to there goes through the integration of all of the infrastructure and chains that we've built with each other. And that possibly one of the most important roles that Bitcoin can play is by unifying the rest of the world of crypto. So thank you very much, and I will, with whatever time I have left, happily take any questions. Thank you. You, sir, and then you. Yes, please.
Hi. So are you saying that ultimately Ethereum should become a Bitcoin rollup?
I think Ethereum always wanted to be a Bitcoin rollup. Because, and why do I say that? Ethereum's founder started in Bitcoin, created Ethereum as a way to try and achieve what he hoped Bitcoin could become, but felt like Bitcoin didn't have the tools to achieve. And ultimately, the goal that I think Ethereum, and Bitcoin, and really people who are in this space, less for the Ponzi and more for the sort of ideological aspects. What we would like to do is build a world of concrete property rights that are borderless and can be transacted by everyone. So I know you were being a bit facetious by saying Ethereum as a Bitcoin rollup. I think what we should look towards is a world in which these systems are deeply integrated. And I think if we ask ourselves, does it really matter which system becomes the sort of default layer of trust? It doesn't really matter. I just personally, for multiple reasons which I'm happy to discuss, think Bitcoin is the most likely. But I think one of those I already mentioned, which is network effects. Thank you. Yes, sir. I think they want you on camera, or at least in the audio.
Okay, thank you. I have a question related to the scalability of Bitcoin. If you feel that Bitcoin is going to be the substrate of trust in the new world, as the internet is for data, and the digital economy of the information.
Yeah.
I would like to understand the bottleneck in terms of how many proofs you can put on a single block, etc. I mean, it seems that we are not yet.
So the proofs that we work with are extremely small, 300 bytes. They represent almost no weight at all. However, usually, almost invariably, they require additional inputs, and that requires additional data. So typically, for transactions or applications on Bitcoin, we're looking at something like 2 to 9 kilobytes, right? Which is roughly on the order of a standard or a slightly large Bitcoin transaction. But Bitcoin itself is extremely limited, right? So Bitcoin itself only gives you 4 megabytes of effective space every 10 minutes. So where do we go from here? I think that two things are going to happen. One is that Bitcoin block space itself is going to become extremely valuable and extremely scarce, possibly the most sort of limited digital resource the world has. Second, I think we're going to see a significant emphasis on proof aggregation and being able to utilize that space in that way. What I think is going to be sad for most Bitcoiners, and that will include me, I suppose, as well, is that I think the implication is that Bitcoin main chain, as we think of it, as a thing that regular people like you and I, transact on, will eventually become a thing of the past. Bitcoin itself will become a settlement mechanism, and almost invariably everything that settles to Bitcoin will actually be an aggregation of multiple other transactions.
All right, thank you.
Thank you very much, everyone.
You can still ask some question outside if you want.